What if I told you that the most advanced engineering on the planet isn't happening in some high-tech lab? What if it's happening right in your own backyard? We're about to look at some feats of construction and precision that are just impossible, and they've been hiding in plain sight this whole time. I want to start with just one number, 5, as in 5 times stronger. Just keep that number in your head for a second, because it represents a level of performance that our best human engineers, with all our technology, well, they still can't touch.
So what could possibly be 5 times stronger than steel pound for pound? Is it some kind of super dense wood from a lost forest? A rare crystal from deep inside the earth? What could it be?
The answer is spider silk. That's right, a single, almost invisible thread that is one of the toughest materials known to exist. It's an absolute marvel of biological engineering.
Okay, so let's crack open our first case file on this incredible superfiber. How in the world does a spider create something so impossibly strong from, the simplest ingredients imaginable?
You'd think the secret would be some super complex recipe, right? But get this, at its core, spider silk is just protein. Yeah, it's made of the same basic stuff as our own muscles, but it's spun into a material stronger than steel. The magic isn't in what it's made of, it's in how it's put together. Part of it is super orderly, like perfectly stacked Legos. The other part is kind of messy and flexible. It's that combo, strength and flexibility, that's the key.
And that, right there, is the billion-dollar question. If we know it's just protein, why haven't we been able to copy it? We can make proteins in a lab. It seems like it should be pretty straightforward, right? Well, this is where the story gets really, really interesting. Turns out, knowing the recipe isn't nearly enough. You have to know how to cook it. And the spider's method, it's a very closely guarded secret. So scientists tried the logical thing. They took real spider silk, dissolved it back into its liquid protein soup, and then tried to respin it using all our fancy, high-tech equipment. And the result? A brittle, weak fiber. Totally useless. It proved the secret wasn't just in the stuff itself. And this gets right to the heart of the problem. Over on the left, you've got the material. We have that part down. It's just simple proteins. But on the right, you see the process. That is the missing piece. Nature has mastered the how, a manufacturing process that lines up those protein molecules with a perfection we just can't copy. And here it is, the secret. The spider's spinneret isn't just a simple little nozzle. It's like a revolutionary microfactory. As the liquid protein comes out, the spinneret spins it at incredible speeds. You know how you twist a rope to make it stronger? It's the same idea, but on a molecular level. This crazy fast rotation forces the protein chains to just snap into perfect alignment, creating that unbelievably strong structure. And here's the kicker. We know that it spins. We just have no idea how. The exact mechanics of how a spider controls this tiny, high-speed process with such insane precision, it's still a complete mystery. It's one of nature's great unsolved engineering problems.
Okay, so the spider is a master of material science, no doubt. But nature's genius isn't just about creating super materials. Some of its most incredible feats are in mechanical engineering, making precision tools that we can only dream of building.
And that brings us to our second case file, the humble acorn weevil. Now, don't let its size fool you. This tiny insect is a master of precision mechanics, with a couple of abilities that honestly put a lot of our own technology to shame. So the question is one of pure precision. How does an insect with, a pretty simple nervous system pull off tasks that would need advanced tools and a lot of math for a human to do? The weevil's first trick is, it's almost unbelievable. To get a home ready for its egg, it finds the perfect oak branch and starts to cut it. And we're not talking about some ragged chew mark. It makes a clean, precise cut at a near-perfect 90-degree angle. Just try to imagine doing that with your teeth. And why do all this? For one single precious egg. Before it cuts the branch, the weevil uses its other amazing tool to drill into a hard acorn on that branch and lay its egg inside. The branch falls to the ground, and the larva now has a safe, food-filled home to grow up in. It's an absolutely incredible survival strategy.
And this is the weevil's second engineering marvel. That long snout isn't just for poking. It's an expandable drill. It can bore a teeny tiny, minimally invasive hole into the hard shell of an acorn. Then once it's inside, the tip can actually expand and move around, carving out a much bigger chamber inside for the egg. It's a tool nature perfected millions of years before we even thought of the concept. So, what's the point of all this? What do we do with this knowledge? Because these aren't just cool bits of trivia. They are literal blueprints, roadmaps for the future of human technology.
And this is where it gets really exciting. The weevil's expanding drill has already inspired our engineers. People are developing new, minimally invasive surgical tools that can go into the body through a tiny little hole and then expand to perform really complex surgeries. It's even helping with designs for safer drills for hazardous waste or for exploration, where making a small entry point is absolutely critical.
You know, this really says it all. For centuries, we've looked to our own brains to solve every problem. But maybe, just maybe, the biggest innovations are already out there, perfected by evolution, just waiting for us to stop and pay attention.
And that's what I want to leave you with. We've only looked at one spider and one weevil, but the natural world has millions of other species, and every single one is a master of its own unique technology. So the real question is, what other impossible engineering is out there, just waiting for us to finally notice?